In a noteworthy declaration that could change our situation in the universe, NASA has announced the discovery of the first extraterrestrial signs coming from the heading of Proxima B, the nearest known exoplanet to Earth, found just 4 light-years away in the livable zone of its star, Proxima Centauri. This revelation has created an influx of fervor and interest. Could this be the moment when humankind finds that it isn't the only one in the universe? The way to this earth-shattering disclosure started with careful observation by NASA's powerful telescopes, which have been observing far-off stars and planets for indications of life. Proxima B has forever been a main competitor in the quest for extraterrestrial knowledge due to its Earth-like attributes and its nearness to our own planetary system. The signal identified is particular and unlike anything stargazers have ever seen before, marking a potential defining moment in mankind's history. The ramifications of such a discovery are significant. First, it affirms the well-established scientific theory that life could exist on different planets under Earth-like circumstances. Second, and perhaps more captivating, it raises the question of the nature of the civilizations that could dwell there. Would they be simple microorganisms or advanced creatures, perhaps capable of interstellar communication and travel? This signal from Proxima B isn't just random noise or a natural cosmic anomaly. It carries an organized repetition that suggests an intelligent origin. NASA researchers, alongside global teams, are now tasked with unraveling this message, attempting to figure out its content and the intentions behind it. The worldwide academic community is abuzz with theories and speculations about the possible substance of this message. A greeting, a warning, or something entirely unexpected. News of this discovery has gone beyond the bounds of mainstream science, sparking discussions via social media, in government rooms, and around dinner tables. People are gazing toward the stars with renewed wonder, considering creatures who may be doing the same on a distant world. How similar or different could their reality be to our own? What might their society be like in terms of technology and culture? These possibilities seem as vast as the universe itself. Furthermore, this discovery opens up numerous ethical and existential questions. How might humankind respond if the signal, in fact, came from intelligent creatures trying to communicate? What protocols should we establish for interstellar diplomacy? Most importantly, how might such a disclosure change how we understand religion, life, and our very way of being as humans? While excitement grows, there is also noticeable caution. Researchers at NASA and other space agencies are working tirelessly to confirm these findings, ensuring that the signal is not a false positive or a distortion. We are on the brink of what could be the most significant discovery in humankind's history, so the next steps must be taken with precision and responsibility. The world waits eagerly for more detailed investigation. The detection of extraterrestrial signals from Proxima B not only propels our scientific endeavors into a new era, but also unites us with a shared sense of curiosity and hope. We could be on the verge of answering one of the oldest and most significant questions. Are we alone in the universe? In April 2019, a radio transmission was detected coming from space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it might seem a great distance, it is the closest star to the Sun, being multiple times farther away than the third brightest star in our sky. The signal comes from a triple star system made up of the binary pair Alpha Centauri A and B and Alpha Centauri C, otherwise known as Proxima Centauri. Alpha Centauri A shines with yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange tint. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is slightly smaller, so our Sun fits precisely between them in size. But where did the signal between these two stars come from? The remarkable discovery has been named Breakthrough Listen Candidate 1, BLC-1. The project, with roughly $100 million in funding, has used years of observation with cutting-edge telescopes around the world. The signal was identified by the Parkes Radio Telescope in New South Wales, Australia. This telescope was observing the area of Proxima Centauri, the closest star to our Sun. The signal almost slipped through unnoticed among the vast volumes of data gathered over several years, but the researchers managed to identify it like a needle in a haystack. For the signal to be considered significant, it must have two distinct characteristics. First, it must be confined to a narrow frequency range, as radio transmissions are not typically produced by natural phenomena in space. Second, the frequency should fluctuate according to the general movement of the exoplanet relative to Earth. The researchers had to analyze nearly 4 million individual signals captured by the telescope in Australia. After a thorough process of sifting and discarding unnecessary signals, they found 5,000 distinct signals, among which one stood out, a signal that couldn't be explained. After cross-checking with contemporary radio transmitters on Earth, this unique signal, with its narrowband mechanical signature, possibly only appeared when the telescope was pointed toward Proxima Centauri and was observed over a 30-hour period. After investigation, it was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method, which detects variations in a star's position caused by the gravitational pull of orbiting planets. The star traces a small circle, and incredibly sensitive spectrographs are used by scientists to track the light from a star. The spectrum of light shifts slightly toward blue as the star moves away from us, and when these shifts occur repeatedly in regular patterns over days, months, or years, it is believed that the variation in light is caused by the gravitational pull of an orbiting planet. On closer examination, Proxima B turns out to be nearly the same as Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world with a similar density. However, there are huge differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star, at only 0.05 astronomical units, while Mercury is 0.39 astronomical units from the Sun. This proximity would make Proxima B an incredibly hot planet, but since Proxima Centauri is a faint red dwarf, the planet receives only 60% of the energy that Earth gets from the Sun, placing it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have found a remarkable 4,935 exoplanets and have recently added 65 new planets to our count, bringing the total to 5,000. This latest group of 65 exoplanets was added to NASA's exoplanet catalog on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope of all time, being multiple times more powerful than its predecessor. With its help, we will be able to unlock the secrets of the vast expanses of the universe. We have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as very hot planets and habitable ones. Among these discoveries, a few planets stand out, particularly Kepler 1649c, which has attributes nearly identical to Earth. In fact, it is the most habitable planet we have seen so far and could harbor life. To date, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially due to the James Webb Space Telescope, who knows what more we will be able to accomplish in the future. Wouldn't it be amazing to find a planet capable of supporting life? One of the primary objectives of the James Webb Space Telescope during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the possibility that they could contain water and organic life. JWST research on star and planet formation allows us to connect studies of mature exoplanets to their birth conditions as well as relate our own solar system to their origins. JWST's infrared capabilities are ideal for revealing how stars and planets form for three key reasons. Infrared light enters dust well, identifies the thermal signatures of young stars and planets, and shows the presence of key chemical components like water and organic molecules. Mid-infrared light can pass through clouds that are many times denser than visible light, which is especially important when observing young stars hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars. But there's more to these star-forming clouds than that. Both young stars and giant planets begin as enormous expanded structures that gradually contract over time. As young stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible frequencies. This means that the Webb telescope will be exceptional for discovering new stars and planets and helping us understand the physics of their formation. With its instruments, JWST will also search for hot atomic gas near various young stars, which could indicate the development of potentially habitable rocky planets. Not surprisingly, much of the James Webb Space Telescope's early science work will focus on determining how planetary systems form and molecules that might be crucial for the development of life. The search for extraterrestrial life has long captured the imagination of humankind, driving scientific inquiry and speculative fiction alike. The recent detection of signals from Proxima B represents a major milestone in this journey, potentially heralding the discovery of life beyond Earth. As scientists continue to analyze and decode these signals, the implications for our understanding of the universe and our place within it are profound. Proxima B orbits Proxima Centauri, a red dwarf star located just over 4 light-years from Earth in the constellation of Centaurus. Despite its relative proximity in cosmic terms, reaching Proxima B with current technology remains a formidable challenge. The journey would require spacecraft capable of traveling at a significant fraction of the speed of light, pushing the limits of our engineering capabilities. The signals detected from Proxima B show characteristics that distinguish them from normal cosmic phenomena. Their organized repetition and narrowband signature suggest an intelligent origin, possibly signaling intelligent communication. This possibility raises fascinating questions about the nature of the civilization responsible for these signals. Are they like humanity, with aspirations for exploration and communication across the universe? Or do they represent a form of life and intelligence vastly different from anything we have encountered before? The discovery of extraterrestrial intelligence, if confirmed, would have sweeping implications for our understanding of biology, evolution, and the conditions necessary for life to thrive. It could offer insights into the variety of life forms that may exist beyond Earth, and provide new perspectives on the potential for life in extreme environments. Additionally, it would challenge fundamental assumptions about the uniqueness of human intelligence and the role of consciousness in the universe. In addition to its scientific significance, the detection of signals from Proxima B has sparked widespread public interest and discussion. Conversations range from the practical implications of interstellar communication protocols to philosophical reflections on humankind's place in the universe. The prospect of contact with an extraterrestrial civilization evokes both excitement and caution, prompting reflections on our responsibilities as stewards of Earth and representatives of humanity. Moral considerations surrounding the discovery of extraterrestrial life extend beyond scientific inquiry to include broader cultural and societal implications. How would the discovery of intelligent extraterrestrial life impact religious beliefs and philosophical perspectives? Would it unite humanity in a shared sense of wonder and curiosity, or would it provoke fear and uncertainty about the unknown? The search for life beyond Earth is not limited to radio signals from distant exoplanets. Advances in astrobiology and planetary science have expanded our understanding of potential habitats for life within our own solar system. Moons like Europa and Enceladus, with their subsurface oceans of liquid water, offer tantalizing possibilities for microbial life adapted to extreme conditions. Future missions to these icy worlds, equipped with advanced instruments capable of detecting biosignatures, could provide definitive evidence of extraterrestrial life closer to home. The James Webb Space Telescope represents a significant leap forward in our ability to study exoplanets and search for signs of life. Designed to launch in 2022, JWST will use its advanced infrared capabilities to peer deeper into the universe than ever before, revealing new insights into the formation of planets and the conditions necessary for life. By studying the atmospheres of exoplanets, JWST will analyze their chemical compositions and search for biomarkers that could indicate the presence of life beyond Earth. Beyond its scientific goals, JWST embodies humanity's enduring quest for knowledge and exploration. It represents a collaborative effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, united in a shared commitment to unraveling the mysteries of the universe. The telescope's unparalleled sensitivity and precision promise to revolutionize our understanding of planetary systems and the potential for habitable conditions beyond Earth. In parallel with astronomical observations, advancements in artificial intelligence, AI, are changing our approach to analyzing complex data sets from telescopes and spacecraft. AI algorithms can sift through vast amounts of data more efficiently than human researchers, identifying patterns and anomalies that may signal the presence of extraterrestrial intelligence. By combining AI-driven data analysis with human expertise, scientists are accelerating the pace of discovery in astrobiology and expanding the frontiers of knowledge. The discovery of extraterrestrial life, whether microbial or intelligent, would have profound implications for humanity's identity and future direction. It could inspire new generations of scientists, engineers, and explorers to pursue careers in space exploration and astrobiology, fostering innovation and technological advancement on a global scale. Moreover, it would prompt us to reconsider our place in the universe and our responsibilities as stewards of Earth's ecosystems and resources. As we await further developments in the search for extraterrestrial life, it is essential to approach these questions with humility, curiosity, and a commitment to scientific rigor. The quest for knowledge transcends national boundaries and cultural differences, uniting humanity in a common endeavor to unravel the mysteries of existence and explore the vastness of the universe. Whether we find signs of extraterrestrial intelligence in our lifetime or in the distant future, the search for life beyond Earth represents an expression of human creativity, perseverance, and our innate curiosity about the universe. In the end, the detection of signals from Proxima B marks a significant milestone in humankind's journey to understand our place in the cosmos and the potential for life beyond Earth. It highlights the importance of global cooperation, technological advancement, and ethical reflection as we continue to explore distant exoplanets and search for signs of extraterrestrial intelligence. We are reminded of the boundless possibilities waiting for us in the unexplored regions of space.